Hi friends, welcome to Studies with Joy. So, our today's topic is ninth standard Science 1 chapter number 4, measurement of matter. So, we have been continuing this chapter from last two videos. I have made the part 1 and also the part 2 of this chapter. If you have not seen this part 1 and part 2 of this chapter, you can just go through my channel and watch it and then watch this part 3, because their two parts are very important to understand today's part, and this part is going to be very important part, and this is the last part for this end of the chapter. Okay, so I request you to first watch the part 1 and part 2 of this chapter and then watch this part and this video. Okay, before starting, please like and subscribe my channel and also press the bell icon button so that you get the first notification when we upload a video, and also share the video with your friends. So we have seen many of the parts of this chapter. We have seen the atomic mass, atomic number, and how to calculate molecular mass, and also the concept of mole. Now we are going to more further learn about moles and how to calculate the molecules with the Avogadros number, Valency, and more other things we are going to learn. And I just want you to revise the formula for number of moles of a substance. So the number of moles of a substance is equals to mass of substance in grams upon molecular mass of that substance. Now let's start with today's concept. That first is Avogadro's number. So Avogadro is a scientist who has given a number that we are going to learn. He has given a number for obtaining the molecules of a molecules. How many molecules are there? Let's see what exactly he has given. Let's see. The number of moles in 1 mole of any substance is constant. So, in 1 mole, number of molecules are constant in any substance. The Italian scientist Avogadro did fundamental work in this context. Therefore, this number is called Avogadro's number and is denoted by the symbol capital N and raised and A. Later scientists demonstrated experimentally that the value of Avogadro's number is 6.022 into 10 raised to 23. So, a mole of any substance stands for 6.022 into 10 raised to 23 molecules. So Avogadro was a scientist and he did a fundamental work in the counting of molecules in 1 mole of a substance. Okay, so how many molecules are there in 1 mole of a substance? So now later scientists found out that the Avogadro's exact value of Avogadro's number is 6.022 into 10 raised to 23. Remember this number. We are going to use in very much sums. So this is very important number. What is it? 6.022 into 10 raised to 23 molecules. So it is stating that 1 mole of a substance has 6.022 into 10 raised to 23 molecules. How? So it can come as a question that how many molecules are there in 1 mole of a substance. So answer for that is 6.022 into 10 raised to 23 molecules are there in 1 mole of a substance. Okay. Now let's do one calculation for that. How many molecules are there in 66 gram of carbon dioxide? So for that method, molecular mass of CO2 is 44. So we know that molecular mass of carbon dioxide is 44 Dalton. Number of moles in the given carbon dioxide is equals to mass of carbon dioxide in grams upon molecular mass of carbon dioxide, that is equals to 66 upon 44. So So we get the number of moles in 66 gram of oxygen carbon dioxide is 1.5 moles. So now 1 mole of carbon dioxide contains 6.022 into 10 raised to 23 molecules. So therefore 1.45 mole of carbon dioxide will contain 1.5 into 6.022 into 10 raised to 23 molecules. That is equals to, if we multiply 1.5 into 6.00022, we will get 9.033 into 10 raised to 23 molecules. You don't have to multiply 10 raised to 23. Keep it that way only. So we got that 66 grams of carbon dioxide. We first took the molecular mass. We then found out how many moles are there in 66 grams of carbon dioxide. Then we got as 1.4 mole. So there are 9.033 into 10 raised to 23 molecules in 1.5 mole of carbon dioxide. So this way we have to calculate. Okay, so it's very easy. How many moles you get of the question answer as answer, you will multiply it by 6.022 and you 10 raised to 3 and you will get the answer as the molecules. Okay, so now let's go next topic, which is, let's see, valency. So what is valency? Let's see. You have been learning in lower standards about that. What is valency? I will just revise you about that. The capacity of an element in to combine is called its valency. So there is a capacity of every element to combine. That is its valency. The valency of an element is indicated by a specific number. It is the number of chemical bonds formed by one atom of that element with other atoms. In the 18th and 19th century, chemical the laws of chemical combination were used to find out the valency of elements. In 20th century, the relationship if of the valency of an element with its electronic configuration was recognized. So there is a relationship between the valency of an element and its electronic configuration. I will just tell you what is electronic configuration. So you have to just learn the atomic number. So the atomic number of oxygen is 8. So its electronic configuration, you have to divide into it. You have to make first, there are 4 shells, 4 orbits, you can say. They are called as 4 shells around an atom. They depend on the number of electrons. So if the atomic number is 8, so we will divide it as 2 and 6. So in the first shell there can be only 2 electrons and others are being put in the second shell. So there are if we divide into 8 into 2 and 6, so that is the electronic configuration for it. So that was it. So valence is related to that only, and we have got the concept of valence electrons. So what is valence electrons? The last orbit of an atom has that may how much, it may be 2 electrons, 3 electrons. That is the valence electrons. Okay. So valency of an element is indicated by a specific number. Now let's learn more about it. A sodium atom gives away one electron and a cation of sodium is formed. Hence, the valency of sodium is 1. A chlorine atom takes up one electron and forms an anion of chlorine, it is chloride, and thus the valency of chlorine is 1. After the give and take of electrons is over, the electronic configuration of both the resulting ions has a complete octet. Due to the attraction between the unit opposite charges on the two ions, one chemical bond is formed between sodium and chlorine and the compound NaCl, that is sodium chloride, is formed. So I will just explain you what it is telling us, that what is valency exactly. It has taken an example of sodium Na and chlorine Cl. So, sodium has this, sodium's electronic configuration is 281. So its atomic number is 11. So it is having one extra electron in the last shell. So he wants to give away that electron. He wants to give away because he wants to make stable his atom. When a atom becomes stable, it becomes only when it has 8 electrons in the its outermost shell. So it has having in the second shell, there can be only 8 electrons. It cannot fit 9 electrons. So that's why he had put the sodium's one electron is extra, so that is coming in the third shell, because only 8 electrons can be fitted in the second shell. That's the rule. So that's why now sodium wants to obtain the state of octet, that is the stable state. So for that, instead of taking 7 electrons from anyone else, it can give 1 electron to someone else. So it is giving it to chlorine. Why? Because chlorine's electronic configuration is 287. So it is having 7 electrons in its outermost shell. What is its atomic number? It is 17. So it is having 7 electrons in its outermost shell. So now it wants only one more to complete the state of octet, that is 8 electrons. So it will take from sodium. So sodium will get a positive charge because it is giving, and chlorine will get a negative charge because it is accepting from anyone else. So when this happens, when an atom is giving, it gets a positive charge and it doesn't remains an atom. It becomes an ion. Okay, we will learn about it more. So how much it is giving is the valency of that element. So sodium is giving one electron, so that the valency of sodium becomes 1, that way. Okay, and that way only the chlorine's valency also becomes 1 because it is accepting 1 electron. So this is the valency. Okay, so that is the valency. Now let's learn about the variable valency. So what is variable valency? Nothing. It is related to just like valency. Under different conditions, the atoms of some elements give away or take up different number of electrons. In such cases, those elements exhibit more than one valency. The property of elements is called variable valency. So I will just first tell you the carbon's valency is 4. Why? Because its atomic number is 6. So if we divide into 2 and 4, we will divide it as 2 and 4 because in the first shell only 2 can come. So 2 and 4, so the valence electron it becomes last is 4. So it can also takes from someone 4 electrons, and it can even give its 4 electrons for anyone else. So in different conditions, the atoms of some elements now give and take, both they do, and means they have more than one valency. So that is becomes their variable valency. So that is the property of that element. Okay. So that is the variable valency. I have given the examples of the variable valency of some elements, such as copper is having variable valency. There are two valencies of copper, so there are also two names: cuprous or copper 1, that is Cu plus, means it is giving one valence is there. Cupric or copper 2, that is Cu2 plus, and that we have given many others. There is mercurous or mercury 1, mercury or mercury 2. So these are that variable valencies. Now let's go on to next topic of radicals and ions. So next topic is radicals and ions. Radicals and ions meaning is the same. Radical and ion. So I was telling when the valency was done, I was telling that after obtaining the state of octet, or after giving or taking some, taking an electron, then the atom is not an atom. It becomes an ion, or we can also call it as radical. Okay, so we can also call it as a radical. So compounds with ionic bonds. So that if, see, we have got that sodium has one positive charge, that is as it is giving, and chlorine has one negative charge as it is accepting. So that positive and one negative attract each opposite signs. You all know now that opposite signs attract, and they form a compound, that is NaCl, sodium chloride, that is the common salt in our house. So that NaCl is formed because of their ionic bond. There is an ionic bond formed between them. That's why. So these are cations, positively charged ions, and anions, negatively charged ions. So compounds with ionic bonds have two constituents. So as NaCl, that is sodium chloride, is also having two constituents. One is sodium and one is chloride. After becoming an ion, if it is an atom, then we will call it as chlorine. And if it becomes, after giving, it accepts, it is not atom. So its name is also little bit changed. It becomes chloride ion. Okay. So there are cations and anions of an element, of a compound. Sorry. So cations are the positively charged ion, and the anions is the negatively charged ion. So cation, when they are formed, when an element gives away its electrons, it is donating, and when an element accepts, it gets a negative charge, that is anion. So NaCl is a compound and it is having one cation, that is sodium, which is giving. So sodium has a positive charge, and chlorine, which is taking, is also having a negative charge. So it is an anion. Okay. They take part independently. They take part independently in chemical reaction and are therefore called radicals. So they are therefore also called ions and also called radicals. It is seen from the above chart that different bases such as sodium hydroxide, potassium hydroxide are formed when various cationic radicals are paired with the different anionic radical hydroxide. So what is happening when the compounds are formed, they are one of them will be having one cation and one anion will be there. Sodium hydroxide, in sodium hydroxide, sodium is a positively charged cation, and hydroxide is an anion. That's we only just given an example. So hence the cationic radicals are also called basic radicals. So ions are also called as radicals. So after giving or taking, an atom becomes radical. So the positively charged or the cations are cationic radicals are also called as basic radicals. So cations are also called as basic radicals, and different bases are distinguished from each other by basic radicals in them. On the other hand, different acids such as hydrochloric acid, HBr, are formed when different anionic radicals are paired with the cationic radical H+. Therefore, the anionic radicals are all called acidic radicals. In the difference in the composition of various acids becomes clear from the acidic radicals present in them. So the positively charged cations are also called as basic radicals, and the negatively charged anions are also called as acidic radicals. So remember them, they are very important. Okay. So now next topic comes, we will continue with that only first. Generally, basic radicals are formed by removal of electrons from the atoms of metals such as Na plus Cu2 plus, that is copper 2 plus. But there are some exceptions such as ammonium. It is ammonium. NH4 is ammonium. Similarly, the acidic radicals are formed by adding electrons to the atoms of non-metals. So, the acidic radicals are formed by adding electrons to the atoms of non-metals such as chlorine, that is sulfur, 2 minus, but there are some exceptions like that is MnO minus. So what is it is telling us that generally basic radicals are found by they react with metals like sodium, magnesium, and the acidic radicals are formed by adding electrons to the non-metals. So generally it is, but there are some exceptions, such as in basic radicals, ammonium is not formed by a metal. It is not a metal. Okay. So there are some exceptions that it is telling us. Now let's go on forward in this chapter. Now, next topic is monoatomic and composite radicals. There are two more types of radicals that are monoatomic radicals, such monoatomic and composite. So, monoatomic radicals such as Na plus, Cu plus, chlorine minus are called simple radicals. So they are having the atoms or radicals which are having only single one valency is called monoatomic. It doesn't matter which charge it is having, it should have only one valency, so it is monoatomic. When a radical is a group of atoms carrying charge, such as sulfuric acid or anything more, such as sulfate, ammonium, it is called composite radical. The magnitude of charge of on any radical is its valency. So when there are more than two elements coming together, such as it is hydrochloric acid and many more. In hydrochloric acid, H and Cl both are there. So they are also monoatomic because they both are having single valency. But they which are having more than one elements and are having in different types of valencies, such as I have given ammonium. It is NH, nitrogen and hydrogen. So it is a composite radical. It's not an monoatomic radical. So this was the difference between the composite and monoatomic radicals. Now let's go to next topic. It is chemical formula of compounds. How we write the chemical formula of compounds. Before it, let's learn something about it. The characteristics of a compound formed by ionic bonds is that its molecule has two parts. These are a cation and an anion. It is a basic radical and an acidic radical. These two parts are oppositely charged. The force of attraction between them constitutes is the ionic bond. The name of an ionic bond contains two words. The first word is the name of the cation and the second is the name of the anion. So when we write a ionic bond or a compound, it will have first it will be the cation and then the second will be the anion. We cannot write first anion. The charges are not shown through the number of the ions is written as a subscript on the right of the symbols of the ion. In the case of composite radicals, the number is written as subscript outside the bracket enclosing its symbol. This number is obtained easily by the method of cross multiplication of the valencies. So this you will understand by writing the formula that we are going to learn about the steps. How to write the formula using the valencies, and sometimes the valency and the formula will be matching not. I will make you understand. Just let's see. We will just understand it by the steps which are taken for it. So let's see. These are the steps to write the molecular or formula for a compound. To write first step 1, to write the symbols of the radicals. So we have to first write the symbols of the radicals. So basic radical on the left always. Okay, basic radical on the left because it has been the first will be the basic radical and second will be the acidic radical. Okay. So we are taking an example of sodium and sulfate. Sodium sulfate. So Na and SO4. Then step 2 is to write the valency below the respective radical. So we have to write the valencies of that radicals. So sodium valency is 1 and sulfate valency is 2. We have written below it. Step 3, to cross multiply as shown by the arrows the number of the radicals. Now we have to cross multiply the valencies. So now 1 will go with SO4 and 2 will come to Na. So step 4 is to write down the chemical formula of the compound. Now we will write down. So as 1 goes to SO4, we will not consider 1, and Na goes to 2. 2 goes to Na, it will become Na2SO4. Okay. So in this way, if it would have been both the valencies would have been 2, then we would have not write like that, because it becomes constant because both is 2. And if one of them would have been 3 and one of them would have been 2, so we have to write as Na2SO whole wise 3. What is whole wise? We will put it SO in bracket, because SO is already a compound, because it is a mixture of sulfur and oxygen. So we have to make a bracket and then we will write the extra one, that is 3. Then only it will be applicable for both sulfur and oxygen. If we just write with oxygen, down the oxygen, then it will be applicable only for oxygen. It will be wrong. Okay. So in order to write the chemical formula of compounds, it is necessary to know the valency of the various radicals. And okay. So now we will be finishing with this chapter here only. Please like and subscribe my channel, and also thanks for watching. So we have finished this chapter.